Hi and welcome all of you to this class on proportions. I hope you have watched my video on the ratios class that we had discussed earlier. Okay, because in this class we'll continue from where we left in that class. In case you have not watched the ratio class, please pause, go back, watch that class, solve the questions, and then come to this class because then you'll be able to understand this better. Okay, so let's get moving. If you remember, in ratio, we had discussed that anything of the type A is to B, which we write like this, is called a ratio. Okay, so if I say A is to B is 3 is to 2, I can also say A by B is 3 by 2, right? So this A is to B is a ratio, and this colon in between, this is read as is to. So A is to B is what this is called. Now, proportion is nothing but where you put two ratios with a equality sign in between. So I say A is to B is equal to C is to D. This is nothing but a proportion, which if I write as a fraction, it is A by B is equal to C by D. This is what is a proportion. Okay, very simple. So it is two ratios with a equality sign in between. Okay, this is one format of writing this. Another format is, I write this as, let me use a different color. I can also write this as A is to B is as C is to D. Okay, so notice carefully, I have used two colons in between. Okay, so this I told you earlier, this is to, and this two colons in between, this is read as is as. Okay, and this obviously is to. So you read this as A is to B is as C is to D. Okay, so you can write it like this, or you can write it like this. Either way, it is called a proportion. Okay, and both of these will mean this: A upon B is equal to C upon D. So this is the very, very basic and core concept of a proportion. Okay, so basically the equality of two ratios is called a proportion, as I told you just now. So if A by B is equal to C by D, then A, B, C, D are said to be in proportion. So equations with two equal ratios, 2 by 3 is equal to 4 by 6, this is a proportion, or 5 by 15 is equal to 1 by 3 is a proportion. If A is to B is equal to C is to D, then we write them as I told you just now, A is to B is as C is to D, and then A, B, C, D are said to be in proportion. Okay, also when you write it like this, notice here that my terms which are at the corner, the starting term and the ending term, these terms are called the extremes. Okay, and the two terms which are in the center, your B and C are in the center, they are called the means. Okay, so they are called the means. This is a terminology that we use. Okay, and obviously when you write them in a fraction format, you can see A upon B is equal to C upon D, and as a fraction you can cross multiply them. So basically you can see A gets multiplied with D, that means the extremes get multiplied. B gets multiplied with C, that is the means get multiplied. So we say that product of means is equal to product of extremes in a proportion, or if A is to B is equal to or is as C is to D, then A into D is equal to B into C. Product of means is equal to product of extremes, or product of extremes is equal to product of means. Hope we are clear till here. Okay, great. So let's move on from here and let's see. Let's solve a basic question before we proceed further. Okay, so let's say a rectangular plot 40 meters long and 75 meters wide. Another rectangular plot is proportionately smaller with a length of 32 meters. So the first one is 40 meters long. So 40 upon 72, and this 40 is length. So for length I should write 32, and breadth I don't know, I should write x, right? So this is what it means. 40 is to 72 is same as 32 is to x, right? Good till here? So basically we have to find the value of x. Okay, very simple. Let's first reduce them. This can be 4 and this can be 5. So you have x is equal to 72 into 4 upon 5. Sorry, this was not 72, this was 75, my bad. This is 75. Okay, so this is 75. So once I have this 75, this is 15. So 15 into 4 is equal to 60. So you can see that 40 upon 75 is equal to 32 upon 60. Okay, this can get cancelled as 4. This will be 5. This will be 15. This will also be 15. So net you have 1 by 15 is equal to 1 by 15. You get the same value. Okay, so obviously these two are in proportion, or 40 is to 75 is in proportion to 32 is to 60. Hence your answer is 60 for this question. Okay, very simple concept. So this is a very simple application of the concept of proportion. Okay, let's understand few more terms and few more rules regarding proportions, which will help us in some further questions. Okay, before that, can we do one more question? So what is the least number that should be subtracted from 18, 26, 32 and 47 so that the resulting numbers will be in proportion? Okay, so we have to subtract something. So basically what it means is 18 minus x. Let's say the number that is to be subtracted is x. 18 minus x upon 26 minus x. And remember, when we say these numbers to be in proportion, this is the first, this is when they are in proportion. We'll come to first and second proportion in a bit. But when they are in proportion, basically 18 is to 20, this is to this, that is the set. And we have to subtract something. So it basically means 18 minus x upon 26 minus x is equal to 32 minus x upon 47 minus x. Okay, now there is a long method to solve this question and there is a short method. Long method, of course, is cross multiplying, but then you will get quadratic equation in terms of x, and then you'll have to solve that. But that quadratic, if you notice, will actually get cancelled. X square on both sides will get cancelled. Okay, so but still you'll have to do 47 into 18 and 32 into 26. Okay, so that is the long method. Do you want to do that long method? Okay, let's try. 18 minus x into 47 minus x is equal to 26 minus x into 32 minus x. Okay, now how much is 18 into 47? 8 into 7, 40, 48, 56, 5 carry, 7, 5, 12, 12 plus 32 is 44, 4, 4 carry. 846 minus 18x minus 47x plus x square is equal to, okay, 26 into 32, 6 into 2, 12, 2, 1 carry, then you have 4, 1, 5, 5 and 18, 23, 2 carry, 6 and 2, 8, 32, minus 26x minus 32x plus x square. Okay, in case you're wondering how did I do that multiplication, let me just digress a bit to explain that. What I used was a diagonal method of multiplication. Very simple and powerful method. Let me just take a minute to explain that to you. When I'm multiplying 32 into 26, basically what I do is I multiply the right hand digits first. 6 into 2 is 12, so 2 and 1 carry. Okay, just remember that one. Then I cross multiply this and I cross multiply this and I add them, and of course I add the carry. So 6 into 3 is 18 plus 1 carry 19 plus 2 into 2 4, 19 plus 4 23. So 3 and 2 carry, and then I cross multiply this. 3 into 2 6 plus 2 8. Understood? No? It was too fast? Okay. Let me write the 3 steps separately. Let's say this is my number. First step, second step, third step. So in my first step, I multiply the 2 right-hand digits. I multiply these 2. In my second step, I multiply this, and we add them. And in every step, you add the carry from the previous step. Okay, and in third step, I multiply this. That's all. Okay, so you can see the right-hand side, you have 6 and 2. So 6 into 2 is 12. 2, you carry 1. So let me write 2 here. 1 carry. So 2 into 2, then you do this 2 into 2. So you do 4 plus 1 carry, 5. 5 plus 6 into 3, 18. 18 plus 5 is 23. So 3, 2 carry. So 3, 2, and then 2 carry. Then in the third step, you multiply 3 into 2, which is 6. 6 plus 2 carry, 8. So 832. Okay, so that's how we do this. Okay, hope you have understood this. Let's also understand how you do when the numbers are written like this. The number 26 into 32 is written like this. Then what this means is that first you multiply these 2 numbers. Okay, the 2 right hand side numbers. So again 16 into 2, 12 ka 2, 1 carry. Then you multiply this and this. That means you multiply the extremes and the means. Okay, so not extreme mean here, but same concept. So 1 was your carry, then 2 into 2 4 plus 1 5, 5 plus 18 23, 3, then 2 carry, and then you multiply this. 3 into 2 6 plus 2 8. So that's how we do this cross multiplication. Okay, so do practice this a bit, very useful. Though in CAT exam and a lot of other exams, you do get an on-screen calculator, but this is faster. So on-screen still you'll have to type the number. Okay, this can be much faster. Okay, so as I was telling you earlier, you can see that x square gets cancelled, and that is the advantage here. My x square is getting cancelled. So what I have is 846 minus 832, that gives me 14, is equal to, I have 26 plus 32, that is 58x. So that is what you get here, minus 58x, and plus I have 47 and 18, 47, 57, 65x. So net I get 7x. 7x is equal to 14, that means x is equal to 2. So this is the long method of solving this question. What is the short method? And there's a very interesting short method, and this is one thing that you must practice as much as possible. In a lot of these exams, which are multiple choice exams, the answers are there to help you. Why are we not taking help from the answers? So why should I solve all this? Why not just fit the answers and check? Okay, so let's look at a second method where I just fit the answer. For example, the first answer is 1. If I reduce 1, I get 17 upon 25 is equal to 31 upon 46. You can see that they won't cancel. So this clearly is not the answer. If I reduce 2, then I get 17 upon 24. No, not 17, sorry, 16. 16 upon 24 is equal to 30 upon 45. Right? And 30 upon 45 is nothing but 2 by 3. 16 upon 24 also is nothing but 2 by 3. So 2 by 3 is equal to 2 by 3. Hence automatically second one is your answer. So lot of these questions, in fact, we should take help from the answer choices, and you'll be able to solve the questions in a jiffy. So do try that, and that will be useful at a lot of places for you. Okay. So in fact, going forward, any question, in fact, my suggestion will be read the question, scan the answer choices, then solve. Because that will tell you how should you proceed. Should you use the answers? Should you normally just substitute some values in the question? Or should you actually solve the long method? Okay, and remember, you are always competing against time. You always have less time. So wherever you can minimize some time, nothing better than that. Okay, so do remember and do practice, and we will also use it wherever possible. Okay, though I'll try to show you from the long method also, but we will do the short method as well. Okay, fine. Let's do one more question. If A is this and B is this and A is equal to what? A is equal to B, then what is the value of X? Okay, so now the problem is A is 3 by 11 is to 5 is to 9. Now this can confuse a lot of people. This itself is a proportion. Okay, but this is not a proportion. If you remember, for a proportion in the center, you should you get this? No. What do you get in the center of a proportion? You get either double colon, right? You get double colon or you get equal to. You get colon only in case of a ratio. Only in case of a ratio. So A is a ratio. B is also a ratio. And they are combined by a proportion. They are combined by equality sign. Hence, this basically means 3 by 11 upon 5 by 9 is equal to X upon 1 by 27. This is the ratio, and the values in the ratio, they are a fraction, which is fine. They need not be integer, right? So this is how it is. Now here you can see one cancellation straight away is this. This can be 3. So when you take the numbers up and down, you basically get 3 upon 11 into 5 is equal to 3x by 1. That's what you get. X gets cancelled, 3 gets cancelled. So you get x into 11 into 5 is equal to 1, or x is equal to 1 upon 55. So this should be the answer. Let's check just for our confirmation whether this is correct or not, makes sense or not. So here I write this as 1 by 55. What do I get? I get 5, right? Okay. So on the left hand side, you have 3 by 5. And on the right hand side, you have 1 by 5 upon 1 by 3, which will get rearranged as 3 by 5. So left hand side is 3 by 5, right hand side is 3 by 5. So obviously 3 by 5 is equal to 3 by 5. It matches. Hence x is equal to 1 by 55. Right? Very simple. One part which could have been confusing here, which I clarified to you right at the start. Colon always represents a ratio. Okay. Equal to sign always represents a proportion. Right? This is what we have to be careful of. Equal to or double colon. Okay. This is what basically would be a proportion. Okay. And then once you realize that, you write them as fractions and you can go ahead and solve your problem. Right? Great. Let's move on. And now let's understand some theory here. So if A is to B is as C is to D, or A by B is equal to C by D, then that means basically A, B, C, D are in proportion. Okay, so then let's understand some terms. In that case, A is said to be the first proportional, B is said to be the second proportional, C is said to be the third proportional, and D is called the fourth proportional. Okay, in sequence. So A is 1, B is 2, C is 3, and D is 4. So first proportional, second proportional, third proportional, and fourth proportional. Very simple. No problem here. Okay. Then see what few changes we can make. A by B is equal to C by D. Okay. I can divide this whole thing by 1 because it is, you have equality sign in between. So any operation that you do on both sides, that will not impact your proportion. So let's say I divide this by 1 and I divide this by 1. What do you get is B by A is equal to D by C. Okay. So either you can say I am dividing, or you can say that I'm switching the places. I'm switching the places. I'm doing cross multiplication, but I'm switching the places. Then also you'll see that you'll get D by C is equal to B by A. Either way, whichever way you do this, this form of our proportion is called invertendo. Invertendo, I guess you should be able to figure out here. Invertendo, basically we have inversed, inverted, so invert endo. So invertendo is what we call this. Okay, very, very simple. So this is invertendo. Okay. And if you see in invertendo, basically we cross multiplied everything. So B went from left bottom to right top, and C came from right top to left bottom. So both of them have interchanged their position. Here also both of them have interchanged their position. In case, let's look at this again. In case both of them do not change their position, okay, but only you interchange the position of this, then what do you get? Then you get A by C is equal to B by D. Okay, if only one of them changes the position. And this is called alternando. So alternate, somewhere from alternate, you get alternando. Okay, so these are properties of a proportion and they're useful in some of the questions. So we should know that. So when both of them have interchanged, that means all values have interchanged their positions, that is an invertendo. When only one of them have interchanged their position, it is called alternando. Okay, then let's look at this again. A by B is equal to C by D. Let's add 1 on both the sides. I can do a plus 1, not to the numerator, but to the whole fraction. Okay, let me just erase this to avoid any confusion. We are not adding this to the, we're just adding it here. Okay, so when you do this, then it will become A plus B upon B is equal to C plus D upon D. And this format is called componendo. Componendo. Okay. Now instead of adding plus 1, I can also do a minus 1. And if you do a minus 1, you will get A minus B by B is equal to C minus D by D. Okay. And this is called dividendo. Componendo, dividendo. Okay. And if you divide both componendo, dividendo, I divide them whole, then your B will cancel, D will get cancelled, and what you get is A plus B upon A minus B is equal to C plus D upon C minus D. This is a very important and useful derivation, and this is called componendo dividendo. Okay, so these are all properties of a proportion where A is equal to B is equal to C is to D. Okay, one last property is proportionality of the sum. Okay, let me explain this by taking example. Let's say 1 by 3 is equal to 2 by 6, which is equal to 3 by 9. I'm taking more than 2, I'm taking 3. 1 by 3 is equal to 2 by 6 is equal to 3 by 9. Okay, so what proportionality of the sum says that if you have proportion like this, sum of the numerators upon sum of the denominators will also be part of the same proportion. So if I add all the three, or let's say I add first and second, what do you get? 1 plus 2 upon 3 plus 6. I add second and third, 2 plus 3 upon 6 plus 9. I add first and third, 1 plus 3 upon 3 plus 9. I add all of them, 1 plus 2 plus 3 upon 3 plus 6 plus 9. All of them are part of the same proportion because all of them will have a value of 1 by 3. Here if you see, this is 3 by 9, which is 1 by 3. This is 5 by 15, which is 1 by 3. This is 4 by, we had added 1 and 3, so 4 by 12, which is 1 by 3. And this is 6 by 18, which is also 1 by 3. So this is proportionality of the sum. When you have multiple values in proportion, not confined to A, B, C, D, but you have E, F also, you can add all the numerators, you can add all the denominators, or any choice of numerators and the same set of denominators, they will also be part of the same proportion. Okay, very, very useful concept. Let's apply these concepts now in some questions. Okay, so let's say we have this question. Now looking at this question, what do you think? Which property should we be using? Which property you think we should be using here? Componendo dividendo? Yes. Okay, so let's say, but one thing you might get confused, you might think that this is of the form a plus b upon a minus b is equal to 9. This is already in componendo dividendo form. Then how do I get it back to the original form? Okay, don't do it this way. You assume the numerator to be a. So you assume the fraction to be of the type a by b is equal to 9 by 1. Okay, so whole of your numerator is a and whole of your denominator is b. And now I'll convert it to the form a plus b upon a minus b is equal to 9 plus 1 upon 9 minus 1. Okay, so when I do that, root 3x plus 4 plus root 3x minus 5, this is a, and plus b. So I'm adding the denominator, root 3x plus 4 minus root 3x minus 5 upon a minus b, root 3x plus 4 plus root 3x minus 5 minus b. So minus root 3x plus 4 plus minus minus will become plus 3x minus 5 is equal to 9 plus 1, 10 upon 9 minus 1, 8. Okay, so this is what I get. Now if I see here, this gets cancelled. Here, this gets cancelled. This is twice, so 2 times. This is also twice, so 2 times. 2 and 2 get cancelled. 10 and 8 become 5 by 4. Okay, so essentially you get root 3x plus 4 upon root 3x minus 5 is equal to 5 by 4. Okay, now let's square on both the sides. So we'll square this and cross multiply. So when you square, on the left hand side the under root will go away. On the right hand side you'll have 25 by 16. So let's multiply with 16. 16 into 3, 48x plus 16 into 4, 64 is 25 into 3, 75x minus 25 into 5, 125. Okay, so if I take 125 on the left hand side, 189 is equal to 75 minus 48. How much do I get? 48, so 25, 27x is 27x. So x is equal to 7. So x is equal to 7. Okay, so this is a classic example of how componendo dividendo can be applied to solve questions. Okay, I hope we are clear. The only care that you have to take is this looks like a plus b upon a minus b format. Don't do that. That will complicate it for you. Okay, because you'll have to do a reverse calculation. Okay, because if you take this as a plus b upon a minus b, then you will have to figure out, the left hand side is not very complicated, 9 also you will have to figure out कि 9 has to be equal to 9 upon 1 has to be equal to x plus y upon x minus y. Okay, so it has to be 5 plus 4 upon 5 minus 4. Two values whose sum gives you 9 and whose difference gives you 1. Though this also you can solve via equation. If x plus y is equal to 9, x minus y is equal to 1, 2x is equal to 10, so x is equal to 5, and if x is 5 then y is 4. If you can figure this out, then a plus b upon a minus b is equal to 5 plus 4 upon 5 minus 4. Hence, a by b is equal to 5 by 4. Okay, hence root 3x plus 4 upon root 3x minus 5 is equal to 5 by 4, and this is exactly what we got here. Okay, so that is also fine, but this piece you will have to figure out, that this is 9 by 1. 9 by 1 should be 5 plus 4 upon 5 minus 4. That's also fine. Okay, otherwise you assume the numerator to be a and denominator to be b and then solve it. Okay, so both the approaches are perfectly fine. Okay, so I hope we have understood this. Let's do one more question. Okay, we have this question here. P is equal to 4xy upon x plus y. Then we have to find the value of p plus 2x upon p minus 2x plus p plus 2y upon p minus 2y. Okay, now this format clearly tells you that you basically need p by 2x. Okay, and then apply componendo dividendo, and this tells you you need p by 2y. Okay, so from this fraction, if I take now 4xy can be written as 2x into 2y upon x plus y. So p by 2x is equal to 2y upon x plus y, and p by 2y is equal to 2x upon x plus y. Okay, so then let's figure this out. From here, if I apply my componendo dividendo, what do I get? P plus 2x upon p minus 2x is 2y plus x plus y upon 2y minus x minus y, which is x plus 3y upon y minus x. And similarly, p plus 2y upon p minus 2y is equal to 2x plus x plus y upon x plus y minus 2x. 2x minus x minus y, which gives me 3x plus y upon x minus y. Okay, now I have to add these two. Okay, so the first fraction, you can see that if I take the negative out, it can be written as minus x plus 3y upon x minus y. Okay, this negative I have taken out, so basically y minus x becomes x minus y. Why I have done that? Because in the second one you have x minus y. So 3, and remember this is whole negative. 3x plus y upon x minus y. So you x minus y at both the places, easy to add, your denominator is same. So you have 3x minus x, so 2x, plus y minus 3y, so minus 2y, so is equal to 2 x minus y upon x minus y, which gets cancelled. You're left with 2. That becomes your answer. Right? So this again is a classic case of componendo dividendo, and you can see how the fraction can be simplified. Okay, I've solved it in a slightly longer method so that you can understand all the steps, but I hope you have got the gist of how this can be solved. Okay, great. So we have understood componendo dividendo, invertendo, alternendo, and we have understood the application of componendo dividendo as well. Now let's understand the application of the other part, which was summation. Okay, so we have this fraction here. A by 6 is equal to b by 5 is equal to c by 12 is equal to this upon 2x, then find the value of x. Now you can see here, the moment you look at the question, do you see the numerator? 5a minus 8b plus 3c. Okay, Fine. So let's do one thing. Let's write a by 6 is equal to b by 5 is equal to c by 12. This is my original fraction, right? Okay. Now, you see here that we need 5a, right? Fine, we need 5a here. So what we'll do is let's multiply the numerator and the denominator both by 5. This will not change your fraction, right? Because we have multiplied the numerator as well as the denominator. So it becomes 5a upon 30. Okay. Now in the second one, you can see that we need minus 8b. So let's multiply b with minus 8, both the numerator and the denominator. So this becomes equal to minus 8b upon minus 8 into 5, which is minus 40. Fine, which is equal to, now for c, you can see we need 3c. So let's multiply this by 3, both the numerator and the denominator. So it becomes equal to 3c upon 36. Fine. So this fraction is same as what was given to us here because we multiplied the numerator and the denominator by the same value. Now using the summation, you know that this fraction will be equal to sum of all the numerators upon sum of all the denominators. Let's add all the numerators. 5a minus 8b plus 3c upon 30 minus 40 plus 36. This is what I get. And now if you compare this portion with this portion, you can see that your numerator matches. So the denominator also should match. So this 2x has to match with what we see here. That is 2x is equal to 30 minus 40 plus 36. Okay. Which is equal to 30 minus 40 is minus 10. Minus 10 plus 36 is 26. So 2x is equal to 26 or x is equal to 13. This becomes your answer for this question. Okay, so this is where we are using the summation property. Okay, so I hope we are good till here. Fine, so this completes our first part where we have introduced the concept of proportion. We have looked at first proportional, second proportional, third proportional, fourth proportional. We saw that product of the extremes is equal to product of the means, and we saw some properties of a proportion, which is your invertendo, alternando, componendo, dividendo, componendo dividendo, and summation. Okay. So thank you very much for attending the class. Do revise all the questions that we have solved and practice some more questions from your exercise material. And then in the next class, we will look at some more detailed and varied types of proportions, okay, which includes continued proportion, and we'll solve some more questions on them. Thank you so much.